Welcome to a new Voltlog. Today we're going to test a range of pocket multimeters by applying transient voltages to their inputs, and we're also going to talk a bit about the CAT ratings and what they mean. As you can imagine, I left this test for a separate video after I have reviewed these meters because it could potentially destroy some of these meters and turn them into bricks. CAT ratings is something we often see marked on measurement tools, and they refer to the measurement category, a method of classification published by IAC, the International Electrotechnical Commission. Different types of circuits will require a different measurement category based on the total energy available in that circuit. For example, CAT 1 is for measurements performed on secondary circuits not directly connected to mains. CAT 2 is for measurements performed on local electrical distribution, such as that provided by a standard wall outlet, be it 110 volts AC in the US or 240 volts in the EU. CAT 3 is for measurements performed on hardwired building installations, for example distribution boards, circuit breakers, bus bars, junction boxes, and industrial equipment, which is hardwired. CAT 4 is for measurements performed on the source of the low voltage installation, like the power input to your home, or the electricity meter or the primary overcurrent protection device. As you can see, a higher CAT number refers to a circuit with higher available power and higher potential energy transients. Within each of these categories we have voltage ratings, and a higher voltage rating means the ability to withstand a higher transient. A meter like the Brymen BM22S, which is rated for CAT 3 300 volts, should withstand a transient voltage of up to 4 kilovolts to meet the rating. And as these are independently tested, we can pretty much be sure that they will meet that standard. To test these ratings, you will need something specialized, special equipment, which is called a transient voltage generator, capable of reaching those levels. I don't have something like that, but I have this guy, the Brymen 887 installation multimeter, which can generate a voltage of up to 1 kilovolt and measure if the insulation breaks. It might not be all that relevant to measure the insulation of a multimeter because it could still fail and remain isolated between the two inputs, but it's the closest thing I've got for generating a high voltage transient and applying that to these multimeters. And that should be similar to any kind of situation that you might encounter in practice, like for example if you are measuring some kind of circuit and that circuit fails, or if something behind that circuit fails and it sends a voltage transient. You might be in the ohms range, you might be in the volts range, it doesn't matter. The multimeter should be capable of absorbing that transient voltage without failing and without generating any dangerous situation for the user. Velectron.com, which is an authorized Brymen distributor, loaned me this meter to perform some testing on these pocket meters, and I will place a link in the description to their website. Please check that out. It's just a simple way of supporting the channel. So the BM887 can only go up to 1 kilovolt, which is below the maximum rating of the Brymen that should be able to withstand up to 4 kilovolts. But I have no doubt the Brymen pocket meters will have no problem with this test. However, the other pocket meters, which have less protection inside them, I don't know, we might see some surprises there. And if you haven't seen the review of these pocket meters, I will place a link on screen right now for you to check it out. Electron is offering a discount coupon code for the Brymen pocket meters, and you'll find that in the description below. So let's open the box of this installation multimeter and see what we get inside. So we get the multimeter itself, which seems pretty big, but I guess you need that space to include the high voltage circuit. There might be some transformer in there, and it also needs to be rugged enough to meet all of those safety ratings. So yeah, it's a pretty thick and big multimeter. A couple of crocodile clips, a couple of probes. I believe these are the standard Brymen probes. They feel very nice. Silicone leads, very soft rubber on the probes themselves. I like these. We get a thermocouple, and we get this special probe that you can use for the insulation test. You can see we have 3 contacts on this probe. So this will be our active probe, and then you will also need to connect the COM to do the insulation test. This also feels very nice. It's soft, but it's a thicker cable, so it's not as bendable as these ones, which are thinner. You see we have a dual display, and the nice thing about this insulation meter is that it's an insulation multimeter. I keep saying meter, but it's a multimeter because it has all the multimeter function that you could want from a good brand name multimeter. It even has a dual display like we're used to seeing on these Brymen multimeters. So I'm not going to do a review of this multimeter because that's going to take us away from the subject of this video. We're going to jump straight into measuring well, not the insulation, but applying that voltage to our pocket multimeters. And I've just looked on the silk screen, and we have to use these 2 outer jacks for insulation. So this is the negative, and this is the positive with the special probe. Yep, and it has jack detection. As soon as I inserted the probe inside the current jack and I was on a voltage selection, it started beeping. That's a nice thing. This insulation probe also has the test button on the probe itself. So that I guess that's helpful in some situations because you don't need to extend back to the body of the multimeter to start the test. Maybe you can start it from right here. Yep, so it's nice. It shows you the test voltage. We were at 1035 volts, and as you can see, the insulation of the air between these 2 probes right now, it's really high. The multimeter cannot actually measure that. It's more than 25 gigaohms. So enough mumbling about the insulation meter. Let's bring in our first pocket multimeter for the test. It's the Aneng AN101, if I remember correctly, because this one does not have the model printed on the front. I'm gonna first try it on volts AC range, and I'm gonna go full blast with 1000 volts because let's not waste our time. And the Brymen is overloading, but we see 10 megohms, which is the impedance of the multimeter. So I think it successfully passed this test. I will also check some measurements behind the camera to make sure it survived, but there's no doubt on the volts range they can survive this, but we'll see what they do on the ohms range. Let's try it on DC as well. So the Aneng was overloading once again and it was beeping, but I believe it was measuring some voltage. Let's try again. Yep, it's measuring exactly the voltage the Brymen is applying. Brymen, it was saying 1035, 1040. It doesn't matter at that level. It's almost bang on. And let's try it on the ohms range on the Aneng and see what this does. Did we kill it? Let's see. I'm just shorting the probes and we're seeing some random results. Let's try our resistor calibration box. Let me get that. It still measures okay. Yep, this is a 66.3 kilo ohm resistor, so it didn't kill it. Let's also try it on the diode. Yep, nothing happens there, though I might need to switch the probes around. It's still measuring okay. Now we're testing the Aneng AN8203 on volts AC, and we're seeing the 10 megohms input impedance. Let's try volts DC. Yeah, it's beeping because it's overloading, but look at how accurate it is measuring the voltage, same as the Brymen. So this has been very accurate throughout our tests. Not sure if it's due to calibration they use or maybe a more accurate multimeter chipset inside. Let's try the ohms range. So it's just showing overload. Let's see if it's still measuring. Well, that's a bit high for just the resistance of the leads, but it's going down. It might be due to crappy leads. Anyway, let's check our reference resistor, which should be 66.3 kilo ohms, if I remember correctly. Yeah, 66.3, and it's still measuring okay. It's showing 66.4. Yeah, that's within the specified range. Let's also try the diode test. It's showing overload. Yeah, but it's still working. Yep, it didn't kill it. It's still working. The Aneng 8203, it's still working. Let's see how the Mastech behaves to our 1000 volt test. And it seems to be doing fine. Let's try it on DC. Yep, so it's beeping at us, but it passed the test. Let's try it on the ohms range. Oh, it's showing exactly 1 kilo ohm. Let's see if this affected the measurement in any way. Nope, it's still measuring just fine. Now testing the UNI-T UT120C. On DC volts, it's measuring our voltage. Let's try AC volts. Let's try it on the ohms range. Oh, it's showing a low battery indicator. Let's see if this affected the multimeter by checking with our reference resistor. Oh, it's still measuring fine. Let's try it in the frequency measurement as well. Well, not showing anything particularly interesting. So I think the UNI-T passed as well. Now let's try the Brymen meters. This is the BM22S. Let's try it in DC as well. Let's try it on the ohms range. On the frequency measurement, let's go back to ohms and check our reference resistor. Yep, it's still measuring fine. Let's also try the BM27. I'm gonna first leave it in its auto function. Let's see what kind of measurement is going to do. Well, it's switched to a low impedance voltage measurement and it's overloading. Let's switch to voltage measurement. Overload. Let's switch to AC. Let's switch back to DC. Yeah, so it can't really show this voltage of 1034 volts because it's overloading. Let's try the ohms range. Yep, it's still measuring fine. So apparently we proved nothing with this test. It only goes up to 1000 volts and all of the pocket meters we've tested have survived just fine the 1000 volts test. Even though it's over the specified range they have on their inputs, they usually only go up to 600 volts, these pocket multimeters. In our case we tested them at 1000 volts and they survived. There was no issue at all. But yeah, it's way below the CAT ratings because as mentioned before, for a CAT 3 rating that they have of 300 volts, they should be able to withstand a 4 kilovolt transient. So yeah, this insulation meter, although very nice and capable, it's not for that kind of testing. It doesn't go up to 4 kilovolts because 1 kilovolts it's enough for the purpose it was built for, to measure the insulation on industrial equipment and circuits. So yeah, I'm surprised. I was expecting at least the cheap Anengs to maybe fail in some way, or maybe even the Mastech to fail in some way at the 1 kilovolt signal. But no, they survived just fine and they still measuring just fine. But this thing is a beauty of a multimeter, although too big to kind of use it on the bench. It's more of industrial rugged use. It's thick, it's heavy, it has all you can expect from an industrial multimeter. But I would not use something like this on the bench. So thank you for watching this video. Don't forget to check out the V-Electron, the distributor who loaned me this Brymen insulation meter for the purpose of this video. As usual, hit the like button and I will see you next time.